We're going to discuss how to determine continuity using graphs. So let's recap on what it means to be continuous or to have continuity at a given point. So it's a three-part definition which indicates that, first of all, the function must be defined at that given input. The second indicates that the limit has to exist. So the limit as x approaches a, or as the limit as x approaches a certain input, the function, it must exist. And then thirdly, the limit as x approaches a of the function must be defined at f of a. So let's take a look at the example we have where we're being asked if f of x is continuous at x equals 3. Now, there's also this common understanding of continuity where typically you're told that you can draw a curve without lifting your pencil, it's continuous. But let's take a look at why this function is not continuous, because that's much more likely a skill you'll have to use perhaps on an AP test, and you'll want to give specifics. So for example, if I'm looking at this curve, I first need to make sure that the function is defined at 3, right? Because I'm asking, is it continuous at 3? It might be continuous at other points, but specifically at 3, what is happening there? So if we look when x is equal to 3, which would be here, do we have a defined output? And in this case, we don't. We have two undefined outputs, one here and one here. So this function would not be continuous because it fails the first part of the definition. Now, not only that, it would also fail the second part of the definition. A limit has to exist. Now, a limit only exists when the left side and the right side both converge towards the same output. But in this situation, if you track the graph from the left side, the limit is approaching -5. If you track the function from the right side, the limit is approaching -1. So not only does it fail the first part of the continuity definition, but it also fails the second part of the continuity definition because the limit does not exist as x approaches 3. Okay, so obviously if it fails the first two parts, it's not going to be able to satisfy the third part either. So is f of x continuous at x equals 3? The answer would be no.